Okay, so let us begin. Last time, what we talk about is creating of subsequences, right? So that is by looking at the sub index of the sequences, and then we created a sequence which is basically a subset of the previous sequence, so that's called subsequence. And then we see the convergence of subsequence, and then we see that the limit of the sequence and subsequence are same if the main sequence converges. And then we see an example of how we can do that, and then the other part I leave it as an exercise. So today what we are going to do is we are going to do one of the important properties, right, which is known as Bolzano-Weierstrass theorem. And so that Bolzano-Weierstrass theorem says that every bounded sequence will have a converging subsequence, right? So that is a very useful theorem which will be used in several places in all the other higher level mathematics which we are going to study, or which you are going to study later on, right? விளங்கல நீயா ஓகே நான் இங்கே லேப் இருந்தேன் நான் இங்கே விட்டுட்டேன் ஹை டெஃபினிஷன்லாம் இருக்கு இல்லையா ரெடி தானே என்ன ஓகே சரி okay, so what we are going to do is we are going to see how we can prove that result, that Bolzano-Weierstrass property, which says that every bounded sequence has a convergent subsequence, because later on in other mathematics courses which you are going to study, you will use this theorem more often, right? So in order to do that, first thing you know that if you have bounded sequence, then if you want to prove convergence, then it has to be a monotone sequence, right? So only if it is a monotone sequence, then only you can have boundedness, and monotonicity implies convergent is what you learn. So first what we are going to do is we are going to say that if we can get a subsequence from a sequence, then that subsequence is a monotone subsequence. So I will do that as a proposition first. Right, so this is the proposition. This says right, so this says every sequence has a monotone subsequence, right? So we can always create a monotone subsequence out of a given sequence, right? So we have to prove this. So we prove it by the way we construct the subsequence, right? So this is how we are going to prove it, right? So the proof is construction. Right, so this is what we are going to do. We are going to construct a subsequence of a given sequence, right? So in a way, what we are going to do is we are going to create it in a way such that it is either increasing or decreasing, right? So this is how we do. First case, right? So in first case, right? So the first case is, let us assume that, right, the set xn for all n greater than some capital N, right? So after a certain point, suppose that the set has a maximum, right? So it has a maximum element for a certain n, right? So in that case, you can always pick a maximum, right? Okay, so here is the point. Right? So if we assume that after certain number, right, if you take all the elements of the sequence beyond that point, right, and then if we say it has a maximum, right, so then what we are going to do is we are going to pick the values of the sequences in a certain order, right? So this is how we are going to do it, right? So for example, so if you have a set like this, right? So if you have a set like this, right, then what you do is, right, so after n greater than 1, right, so first point, after this you take the maximum, right? So let us say here I rearrange them. So let me do this in this way, and so 1, 6, 3, 2, 4, 5, and it goes like this. Or let me say just a finite set. Okay, for example, right? Right. So I have a sequence of 1, 2, 3, 4, 5, 6, but not in the order. Right. So 1, 6, 3, 2, 4, 5. That is how I have the order. Right. So what I am going to do is I am going to oh, 1, 6, here I will put 5, and here I will put 2. Okay, just this, right? So here what I am going to do is first, right, pick the first number, right? N is equal to 1, right? So this is my x1, x2, x3, x4, x5, and x6. So x1, n greater than 1. So everything after that, x2, x3, x4, x5. So I take this set, and in this set, my maximum is 6, right? So that is my xn1, right? So that is my xn1, right? So that is actually x2, right? So after doing that, right, what I do is I go for that 6. Okay, 6 is here. Then what I do is I go after 6 and take the maximum. So clearly 5 is the maximum, right? So that is my xn2, right? And that is actually x4, you know, right? So that is x4. So I go to x4, and after that I go for maximum, right? So in that case my maximum is 4, right? So clearly that is my xn3, right? So like that I can pick up numbers, right? So you can see that I take the whole set of sequences, first element dropped, after everything you take the maximum, pick that maximum as the first component of the subsequence, right? And then beyond that component